I just wanted to double check. Like on like number 1 and number 8, when you write it out, there's zeros like for 1 plus I. You write it x minus 1 plus I.
Yeah,
and then like on number 8, it'd be x plus 1.
I am going to stress that when I get to that with this problem, okay?
Because I was a little confused and I checked the key and then I was like, oh, okay.
Alright, so we're going to bring down this first one and then we're going to multiply and we get 1 plus I. We get 1 plus I when we multiply here. So when we add these two, we're going to be left with a complex number, which might look complicated, but in the end it's not. So this leaves us with negative 1 plus I. So now when we multiply, some of you may need to come over to the side and show that work. Some of you might be able to do it in your head, but some of you will probably need to come over to the side because this is without a calculator. And so we're going to do first terms and outside and inside. And you may have noticed that the outer and inner actually we're going to cancel. Did you notice that without having to do it? Okay. Well, on this one, the outer and inner did cancel. And so it gives us negative 1 plus I squared. But what is the value of I squared? Negative 1. So this is negative 1 plus negative 1, which is negative 2. So now we're going to add here, and this gives us negative 3. My Moby's misbehaving. There we go. And then we're going to multiply. So we do negative 3 times this term. So this gives us negative 3 minus 3i. And then we're going to add. So this gives us 3 minus 3i. Now, we all know we want 0 here. But what I don't want you to do is just assume that this times this is positive 6. Because then you're skipping your whole check step. So if we do 1 plus I times 3 minus 3i, we should see that first terms gives us 3, outside a negative 3i, inside a positive 3i, so those are going to cancel, then minus 3i squared. Well, the I squared is like multiplying by negative 1, so this makes this plus, and 3 plus 3 is 6, so yes, we know we did it right because we got that 0. So that's our check step there. Now, if one of our roots is 1 plus I, what is an understood root? 1 minus I. So that will be the next divisor. So we're going to bring down our first one. We're going to multiply. And didn't you get excited when all this nice things happened? And it canceled. And then you multiplied, and you got negative 3. Then you multiplied, and nice things happened again. It canceled. So what we're left with here is x squared minus 3. And to find the rest of our roots, we would set this equal to 0 and solve. As long as we're left with a quadratic, we can find the roots. If we can't solve it algebraically this way by moving the constant over, we could factor. Or if it doesn't factor, we could use the quadratic formula. So there are several methods. Once we get down to a quadratic, we are good. So on this one, I got 2 other roots, a positive root 3 and negative root 3. So if I made a list of all of the roots of this function, it would be positive square root of 3, negative square root of 3. Positive 1 plus I, negative 1 plus I. Excuse me, that is not negative 1 plus I, that is 1 minus I. Thank you. Okay, now, when I'm writing the complete linear factorization, all I do is take all these roots, I'm going to write it down here so I have room, and just do x minus my first root. X minus my second root. Well, that's going to make this a minus a negative, which makes a plus. X minus my next root. Well, I have to subtract all of this. So it's going to change this positive 1 to the negative 1, this positive I to a negative I. And then finally, x minus, that should be an I. Doesn't look like one. X minus all of this, which makes this a negative 1 and this a plus I. And so you're subtracting the entire complex number, so it changes the signs of everything. So this went from 1 plus I to negative 1 minus I. This went from I 1 minus I to negative 1 plus I. Are we good? Any questions? A little confusing?
The whole minus thing.
Yeah, no, well, subtracting just changes the signs.
I mean, if it goes both ways, can you just like
It's like as if
be cool about it?
Okay. The other problem that first period asked me to work out and show them all of was number 6. So do you see they gave us one root of 1 plus 3i? And so we would bring down the first one, multiply, add, multiply, nice things happen, add, multiply, add, and I did test it. I got 50 here. 5 plus the 45 gave me the 50. I actually multiplied 1 plus 3i times the 5 minus 15i to check. And then did the second step. Nice things happened. And then here are my roots. Positive or negative, square root of 5. 1 plus 3i, 1 minus 3i. So I'm going to do x minus the positive root of 5. X minus the negative. Well, minus a negative makes a positive. X minus all of this. So when we subtract all of this, that's where the negative 1 and the negative 3i came from. And then that last term, this term here, came from subtracting this root. X minus makes this a minus 1 and a positive 3i. Okay? All right. I'm going to have you check the rest of your work. I'll show the division. Here's the roots. And the linear, complete linear factorization is written in blue. So if you'll check the rest, and I'll post these notes so you can check online again if you needed to. And I'm going to come swing through and look for completion while you're checking.
Basically what we did yesterday.
Okay. Well, when we get to do it, just in our
so I thought that you just had to find roots or whatever digits to the third degree. Alright? Or do you but you keep going now?
Well, I would prefer because you could, if you wanted, you could say 4x squared plus 11 plus 4ix
That's why I like that.
minus 3 minus I.
So that's why you keep going.
Yeah, you just keep going. Yeah, it'll be much simpler.
Okay, because yeah, when I got there, yeah, Brian. When I got there, I had really weird stuff. And then I kind of got mad at it. This will look good. So I was talking to Brian about this.
Okay.
You keep going anyway, because what confused me is I got all of this. I'm like, okay, that won't, I'm like, that won't factor. It needs a quadratic formula, and I got really hard. Oh my gosh, this is crazy. And
Thank you for pointing that out. Okay. When we're dividing by imaginary numbers, like we did on, which one is that? Number 5?
I got 4, 5, 7, and 8.
7 and 9. I know
There's no 9.
Okay. So, is everybody done checking 1 through 4?
I'll check.
Okay. If we look at number 5, it is a cubic. And normally I say, as long as we get it down to a quadratic, you can use quadratic formula. But once we divide by that first imaginary number, what we're left with has complex coefficients, so it's not a polynomial, is it? This would be 2x squared plus 3 plus 10ix.
I was freaking out.
So we're not left with a polynomial. So when that happens, you need to go ahead and divide by the conjugate of that complex number so that you are left with a polynomial. That's one of those it doesn't always work cases. Any questions on 5, 6, 7, or 8? Okay. Today we're going the other way. So, yesterday you were given a complex root and you had to find the rest of the roots. Today we're going to do the back side of that worksheet where I give you the complex roots and you have to come up with a polynomial of minimal degree. So, let's flip it over, and I think I'm just going to go ahead and do the same problem with you guys that I did with first period as an example. We're going to do number 18 together, and then I'm going to leave you the rest of them to do on your own.
Does that mean 0 is a double root? It's x squared.
X squared.
That does mean 0 is a double root, which is an x squared. Okay? So 0 is a double root. So if we were writing the factors that represent these zeros, our first factor would be x squared. Excellent. Oops, I need to change pen color. Hold on. Black? Okay.
I'm not.
Okay. Now, what factor would represent the 0 of 4?
X minus 4.
X minus 4. Okay. If one of our roots is 1 plus root 2i,
Oh, 1 minus 1.
then what it's going to be is x minus this stuff, which makes it x minus 1 minus root 2i. Okay, if I ask you to do x minus the root, x minus the root, do you see where it turns into that? Okay, now, if 1 plus root 2i is a root, what must also be a root? 1 minus root 2i. So my next one would be x minus 1 minus root 2i, which what would that give us? X minus 1 plus root 2i. Okay. Now we have to multiply this stuff.
Yeah.
Y'all know where to start, though.
I'll let you
Where
do
do we
that.
start?
Not really.
At the
We
X.
start with the terms.
I don't understand.
Which terms? The last two. Why would we start here? Because these are our conjugates, aren't they?
Exactly. That makes
Okay, so we're going to start there. All right, and what we'll do is we'll just take it one piece at a time. So the first thing I'm going to do is distribute the x all the way through the second factor. So when I distribute this x through this factor, x times x is
X squared.
x squared. X times negative 1 is negative x. X times root 2i is
Root 2ix.
root 2ix. Ooh, that's kind of fun to say. Okay? So that comes from distributing that first term of this factor throughout the second factor. Now, let's tackle the next term. The next term is negative 1. What does multiplying by negative 1 do? Change the sign. So all we're going to do is to change the signs in that second factor. So we get a minus x, a plus 1, and a minus root 2i. Now I'm going to switch colors once again. This is purple, but it looks just like the blue to y'all. It looks different on the computer screen. All right, so now we have to distribute. Well, I didn't use the red. Okay. The negative root 2i through the whole second factor. So it's negative root 2ix. Then positive root 2i. Because a negative times a negative is a positive. Then negative last terms. What's the square root of 2 times the square root of 2?
2.
2.
Negative 2.
And what is I times I? I squared.
But it's
But the I squared has a value of -1, so it makes it a +2.
but it's a negative 2i that you're multiplying.
Yeah.
Right, that's why I had the negative to start with.
Okay.
And then the I squared turned that negative into
I
a
see, I see.
positive.
Alright, so what was left?
Okay, now this is where, just like when we were doing synthetic division, nice things happened. This is where nice things should happen. So let's see if they do. Do you see here I have a positive root 2ix, and here I have a negative root 2ix. Do you see here I have a negative root 2i, and here I have a positive root 2i.
Oh. Beautiful.
And then everything imaginary canceled itself out. And what I'm left with is x squared. And then here is a negative x, and here is a negative x. So minus 2x. And then here is a 1, and here is a 2, so that is plus 3.
Now, is there any shortcut?
Nope. Oh yeah, first period asked me the same thing.
Yeah, usually there's a shortcut.
Usually there is, but there's not really. You know that the i's are going to cancel themselves out when you multiply conjugates, so you know that part's going to happen.
So we don't really have to.
But you just don't know where the rest comes from.
I'm trying to look for one right now.
So once that happens, we don't come forward.
Wait, so we technically don't have to like distribute the.
No, you technically have to do everything I did. Now, if you start hunting for shortcuts and you want to skip steps, then if you see that something happens over and 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 over again, then you can go with that method. But when I work my answer key, I show all the steps.
Now, Miss Willoughby, will the i's always cancel each other out?
Whenever you multiply something times its conjugate, that's what you're forcing to happen.
So, really,
Nope,
I can
nope,
just
nope,
go through and
nope,
do
nope, nope,
everything
nope.
but the i's.
All right. So
Yeah,
now if we
binomials.
distribute through here, do you see we'd get x cubed minus 4x? Do you see that that results in that? So now I've multiplied these two, and I've multiplied those two. So if I just distribute the x cubed through the second,
Should it be 4x squared?
thank you, and then the 4x squared through the second, I'm done. So I'm going to get x to the 5th minus 2x to the 4th plus 3x cubed minus 4x to the 4th plus 8x cubed minus 12x squared simplifies to this function.
So it's not really that hard. It's just.
It's not hard. It's just,
Time
yeah, it's a little
You have
time
to
consuming.
write legibly.
Yep, correct. This is where those of you that might write sloppy could struggle. And there is a polynomial of minimal degree that would have these roots. Now, when we look back at the top, look at number 9. They give us I and negative I.
That's it.
They already gave us the conjugates. So, do we need to add anything to that? No. So if the conjugates are already listed, we don't have to list them. They're already there for us. Okay? The answer key is on the overhead, and you have the remainder of class to work and ask questions.